All right. Hi, everyone. Thanks for tuning in. My name is Greg Robinson. I'm from the Arctic team. And today I'm going to be talking with you about using uh, Consul and Wireguard to speed up development of applications for production inside of Kubernetes. I'm a delivery consultant at Arctic. And the goals for today are to be able to bridge the gap across a Kubernetes network and be able to route to Kubernetes internal endpoints that would traditionally be only accessible via the internal Kubernetes network and bridge that gap as we're developing applications. We will go in later when we do a demo. I'll show how I can, as I develop my application locally on my MacBook, I can actually resolve .consul addresses that might be used in a Kubernetes app in production, but I can still be able to test and actually resolve .consul addresses. So that's the goals are to route layer 3, layer 4 traffic through. Traditionally would only be available inside of the cluster network. So you want to put this in perspective. You might have when people just get started in Kubernetes, they might find a Helm chart for a cool application they want to deploy. It might be a front end web application, and they might deploy that application in their Kubernetes cluster. It might even be like a kind cluster, or they might have a full-fledged Kubernetes cluster running somewhere. And when they deploy it, they try to copy that cluster IP, paste it into their browser, and they're like, oh, it doesn't work. Until they do some reading and they realize, oh, I have to expose that service using load balancer endpoints for it to actually be accessible via a host network. That's sort of what happens. But what I'm going to do is I'm going to say, well, what if I can, bridge that gap from that host network into that cluster network and be able to actually route to every endpoint inside of a cluster I want to. This could be very helpful for development and also even troubleshooting the full breadth of the sort of chain of networking, like service, the endpoint. And so we'll take a look at how we can do that. But those are the two goals. Talk. And so why? I did touch on this just now, but a developer building an application, they might want to be able to actually test the connectivity of an endpoint as they're developing that application locally. They wouldn't be able to do that traditionally, as certain endpoints are only available within the cluster network. That's the why. And to be able to solve the layer 3 problem, I know my camera's covering that bottom right corner there, but it's the same as the Wireguard client 1, different publicly and addressing. And so the way we can do this is using a tool called Wireguard. Now, Wireguard is very lightweight new VPN technology, and it uses new cryptography standards. I've posted my slides in the HashiCorp discuss this course chat, so you can find all the links to Wireguard and look up what the actual cryptography standards are. And the main idea around it is its simplicity in how the authentication happens. So you have private key that only the Wireguard client sees, and then there's a public key, which, for example, the Wireguard server would have. So if we had 10 clients, Wireguard server configuration at the top there would have the 10 public keys for all of those clients, and then all the clients would have their own private key, which they don't share with anyone at all. So that's how the authentication happens, and this allows for applications to be built on top of Wireguard very easily. And as we'll see, and as I'll show, I'm actually using a Helm chart written by a group called Place One. They've actually written a web UI on top of Wireguard, which is what I use to actually configure and create these Wireguard configurations. That allows me to download the configuration and apply it. They even have a QR code generation where I can use my phone to scan a QR code. So I can even use my phone and an SSH client on my phone to actually cluster and curl different things. So Wireguard is a very lightweight client. It's actually available, I think, on every platform. I've even found there's an app on my, if any of you have Google TV, if you type in Wireguard, you'll actually be able to find a Wireguard app for that. Not sure what the use case really is for that, but nonetheless, it's there. And so just diving back into this, the clients all point to the endpoint, which would actually be a public IP. My WireGuard configuration, I'm actually exposing port 51820, which is the WireGuard port, or UDP, and all the clients would point to the public of my router. And I actually use some dynamic TNS. As you know, public IPs on routers change often. That's the layout of how WireGuard works, how the authentication works, how the traffic works. UDP tunnel, very lightweight. Now, if we look at this in the context of the cluster, we can see that we have our host network boundary and we have our container network boundary. And the container network boundary, that's sort of like that 10.244. I have that as in my cluster. That anything that's in that network, I can't just get to it from my home network. So I have a bare metal cluster of about 5 nodes running in my house, and then I also have that WireGuard port opening on my router, and I'm able to connect in the WireGuard client. It actually resolves, so it resolves from my router to that 192.168.0.20 address at that 51820. That's sort of how the traffic enters public to the host and then eventually to the inner network, because the traffic eventually terminating inside of a cluster. So because the traffic is terminating inside of the cluster and I'm running WireGuard inside of the cluster, it actually allows me to route layer 3 traffic inside of the cluster. That's sort of how I can get the layer 3 traffic in. Now, what you'll see in the top right corner there is we have our core DNS configuration, which is at the 1096.0.10. You'll also see that address is what my WireGuard has as DNS. And then that's how I actually resolve DNS. So layer 3 is resolved. So layer 3 traffic is actually solved through just connecting to the tunnel. And then DNS resolution is actually achieved through setting the DNS to the IP address of my core DNS. Core DNS endpoint, that is. And this would allow me to resolve everything .local. So if we take a look quickly about how we resolve DNS without Consul, you'll see that, step 1 is first I have my DNS set to 10.96.0.10 in the bottom left, which matches the cluster IP of core DNS. And then I have, traffic coming in through that load balancer to the WireGuard pod saying, hey, where's flash-web-web.svc.cluster.local? Says, okay, that's right here at where number 2 is, and it returns the web page. That's how it would work. Obviously, right now, Consul is not even in the picture, but you just go like this, install Consul. So I installed Consul with the Helm chart. That's how I installed it in my cluster. And I enabled the service catalog. And so service catalog, what it does is it registers every service automatically into Consul, sort of DNS database where without doing any effort, you can now resolve Consul. You can now resolve your applications using a shorter DNS, sort of a flattened DNS. You don't have to worry about space. You just have to worry about the name, service console. That's how you can resolve. That's exactly how I have it set up here. You'll see that there's an extra hop. We have an extra hop in the situation where because we're resolving .consul is going to say, okay, I'll actually show you the configuration here, but they've added an extra line item in my core DNS config file that says if we're routing to .consul, then I'm pointing it towards the Consul DNS endpoint, which is at 10.1.0.121.61. That's how I route that. And that would all of those resolution requests from outside. So with that, take a big picture view here. Now we have the ability to resolve DNS for .local, and obviously .local resolving using itself, and then I have a forwarding tool for Consul DNS. And I'll share the links on how to set this up for you, whatever configuration that you have, so you can easily get this going. Now, one thing to note is I have that UI there at the bottom. That's how I'm going to register my, which includes like my laptop. I even have a couple servers in GCP that are actually connected and can actually resolve the console addresses. And so I'll show you that too. Okay. All right, let's jump into a demo. I'm going to show you sort of the environment and then some actual routing going on. I'm going to jump over to my code here. If I just show the Wireguard, I think that's the namespace. You'll see that I have those two load balancers. The one load balancer actually fronts for the UDP traffic, which is the actual Wireguard traffic inbound to the cluster. So this is the tunnel traffic. Then we also have a web traffic for the UI. So I'll actually show you what that looks like. Wireguard access portal here. You see that I have all of these endpoints. Again, this is a Helm chart that I found from place one. I have a link, all that stuff. I can add sort of clients here. And what this does more or less is it allows you to scan that. And I'll have to make sure I delete that or it might connect, but that's how you add clients there. Go back here. We look at the Kube system. And look at the stuff in there. See that we have our Kube DNS here. Right? That's the Kube DNS. That's how we're resolving traffic. And then if we look at the console situation that we have, take a look at this. This is going to be quite a few resources. If we go Consul DNS here, so we're basically forwarding. What we're doing is traffic that a .console address to this, so that allows us to solve this. And this is just a service endpoint at port 53 that resolves to the console server. And we also have several different things here that, if you want to learn more about console and all the things that it creates, you'll see that I have these service external endpoint names here that map. We'll actually be able to resolve these. I'll actually show you that now. So if I try to do a curl on any of this, example, Flask web application. Okay, so it is able to resolve because I'm connected. I wanted to simulate me not being able to. Let me deactivate. So again, this is the Wireguard client here. If I go to manage tunnels, you'll see that I have my DNS set to the Kube DNS here, and I have my public key. And the endpoint is this endpoint is my router basically. Yeah. So that's how that works. I point this to my router, so I could be anywhere in the world and actually be able to get into the cluster because I'm actually coming in to my cluster. And so what I'm going to do is deactivate. Now I'm going to try and do it. Can't resolve. Doesn't know how to get there. But once you enable this, business. Now let's Now we have that. We take a look at the use case now. I want to take a look at actually how this comes into production and how you can actually use this to your benefit. The way I'm going to do that is I'm going to drag this down here. Oh, I have a website that I host for my father, and it's called Hip to Give. It's a website that it aims to help Ugandans in Uganda, helps Ugandans essentially build sustainable lifestyles using aquaponics, hydroponics, and also pellet feed systems that help them make money and also themselves. And so this website has a contact form on it. This contact form, what it's doing is I'm using the HashiCorp Vault Python client to point to an endpoint. And now instead of, I initially what I did is I had this as an external endpoint. And so I had this as an external endpoint, but I was like, I can save this and I can maybe just take advantage of Consul, because Consul registers everything with a Vault. Sorry, it registers everything with a Consul sort of DNS address. So that's what I was doing here. So do this. But what happens is if I didn't have this Wireguard tunnel set up into the cluster and I wanted to run this application, right? So you just activate my Python virtual environment here. Not actually going to work because I can't resolve this address. So this might be what you want to have in your production environment. You might want to have other Consul addresses. I'm just using Vault as an example, but any sort of service to service, pod to pod communication where you might have Consul as that intermediary. All right, you might ingress endpoint in Consul to actually handle that pod to pod communication. And so if you don't have, and if you're developing this application locally outside of the cluster, you want to test it quickly. Like Flask is very nice because I can just run everything. Okay, all my changes work. But as you can see, I can't even get that far because I can't resolve this address. So instead of changing this to maybe like bouncer, I'm changing it from what production won't look like, right? You have this sort of problem in this drift. So if I wanted to test this now, if I enable my point here, okay, Python 3, I can now access this. I can now actually start. And so if I go into this, see here, it loads up just fine. If I go to contact and we fill this out, oh, boom. All right, so just like that, it sent me an email. I don't want to show my whole inbox here, but so new message here. Okay, so there we go. What this did, what this actually did was is contacted the Vault. So from my local machine, it actually contacted that .consul, which is contacting Vault. I have this Vault token stored as an environment variable on my local machine. And then I'm contacting the SendGrid Vault to, I'll show that in a minute. Then it's getting all the secrets I need. So if we go down to where that post, so when someone hits the send email button at contact form, that initiates a post request. That post request tracking the using SendGrid. You see here, all this data is coming from, this is coming from the Vault secrets. And I don't have to fill in the secret there. I can just have it there. It's a SendGrid API key that gets, gets retrieved dynamically. And so if I go to take a look at the, so if we take a look at the Consul situation that we have on here, you'll see that I have all these services registered. I actually have services registered in the service mesh. I didn't actually test what I wanted to test initially. If I do kget all, so for example, if we go curl, I can curl anything basically. IP address. Go actually go here -o wide. Get the endpoints. So and you see, so all these, so I can actually, what I can do is actually better dig. I can get these out. I can do a dig for my local machine, get the address. I can curl this, test and see if this works. I can other ones too. Okay, I can be like, okay, I want to do this one. This is actually the individual pod in the replica set. Allows me to that. So I can curl on here. And I can actually see if there's any problems. Thing I need to work out in between the actual pods themselves, in the individual pods, not the whole thing where I'm routing my traffic. So I can resolve .console. I can even resolve the .local. This is where things get kind of I make it look easy, but there we go. That returns that cluster IP. So what's nice about Consul is it actually groups the pods into that one service registration. So as you can see, this is the two differences. We have this one answer section and the answer section here. We have all of the endpoint pods, and we have the cluster IP here. Still accessible, but it doesn't allow me to choose. I can't choose exactly where I'm routing my traffic to. So I don't have the that ability. Okay, and then that's about it. I think I'm trying to make sure that I have everything here. If we go back to my presentation, so just to summarize, we routed traffic in cluster IP. We routed traffic using a .local address, which is showed, and we also used the .console, all from my point. Now, if you just go back here, I wanted to show one thing with Vault here. So SendGrid is, I just wanted to show, just realize what we're accessing. Access the secrets, accessing all of the mail details here for cluster. That's clear. I'm not gonna hit the eye on any of these to show you, but that's that. So we go back here, you can see that the SendGrid maps up with that maps. That's the mount point, the key store. We're obviously path of here, and that gives us access to all the secrets. So this talk was like a Consul, Wireguard, a bit of Vault, fun stuff. Back here. Yeah, that's that. So thank you. I'm pretty active on GitHub. You can find me on LinkedIn. Also find me on Instagram, but I didn't link that here. But all the resources that I use, so see that place one WG access server. Want to try that out and install that. You can do that. I've also linked the HashiCorp console Helm chart, which is what I used when I installed Consul. And then Boring Ton, you can see all that. The Boring Ton is the user space WireGuard. So it's actually basically what the WG access server is. It's installing WireGuard in a user space environment and not a kernel environment. So it allows sort of WireGuard to be run in containers and Docker. You can also find, if you want to see what the cluster I ran everything on and I did this demo on, you can see pictures of the cluster, the Raspberry Pi cluster. Shout out to Jeff Geerling. It's about 5. I have it as 5 nodes now. So I have a Vault, Consul all installed on that. It's all ARM. So, kudos to HashiCorp for, having all this accessible on ARM64 instances. It's actually a pleasure. Not much. There's so many times where I have to build my custom images, but not with HashiCorp. So it's very nice to have that functionality. But yeah, thanks for watching. I hope you learned something. I hope you enjoy the rest of the Hashi Talks.